Okay, our problem. According to statistics reported on CNBC, a surprising number of motor vehicles are not covered by insurance. Sample results consistent with CNBC reports showed 46 of 200 vehicles were not covered by insurance. What is a point estimate of the proportion of vehicles not covered by insurance? Point estimate is our sample value, P bar. Again, that value is a point estimate. It is estimating the population parameter, P, the overall population percentage of all motor vehicles that are not covered by insurance. But we've only taken a sample size 200, so we're going to estimate that. P bar in this case would be 46 divided by 200, or 0.23. So 23% is our estimate of the overall number of motor vehicles not covered by insurance. Now that population percentage is unknown. This is just an estimate. What we're going to try to do next is build a confidence interval so that we can determine how far off our estimate could be when we're using this sample of size 200. So we need the confidence interval for percentages. Notice the standard error of this formula is different than averages. So I'm going to plug everything in. 0.23, we're using a 95% confidence, the z-score in these problems, and putting in 0.23 and the complement of that 0.77, and then dividing by our sample size of 200, I get a margin of error of 0.0583. Now again, this is my margin of error. And what that tells me is that the real percentage of motor vehicles that are not covered by insurance is within 5.83% of 23%. So my 23% point estimate is my best guess, and that's within 5.83% of the real value. Now, there's a formula in this section that allows you to calculate a sample size that will produce a margin of error smaller than that, and it's somewhat similar to the one for averages. There are some differences, but if you're not comfortable with that margin of error, you can reduce that by increasing sample size. The confidence interval then is 0.1717 to 0.2883, or I am 95% confident that the real population percentage of motor vehicles not covered by insurance is somewhere between 17.2% and 28.8%. So this is a confidence interval for percentages. Now, one question you could ask yourself in working with confidence intervals is, are you talking about averages? If you are, then are you talking about a z or a t distribution? Or if you're not talking about average, you're talking about percentages, and use appropriate formula for percentages.